The next notion with vectors in three-dimensional space is the dot product, and that works again in an exactly analogous fashion. Multiply the x components, multiply the y components, multiply the z components, and it follows exactly the same pattern. So if we want to find v dot w in this instance, that's fill in the blanks. That's 4, 6, negative 2, 1, negative 1 times 3. We have 24. Minus 2 minus 3 is 19. So dot product works in exactly similar fashion. It is precisely the same notion as before. It is the scalar product, so when you form the dot product of two vectors, your answer must be a scalar. All right. One of the main uses of dot product is the same as before, is finding the angle between two vectors. So let's find the angle between V and W. I'm going to erase some of this. I'm going to keep my dot product. I've established the dot product as 19. All right. It's the same notion as before. We have the cosine of theta is the dot product over the product of the magnitudes. Well, the dot product we just found, it hasn't changed in the last few minutes, it's still 19. But the product of the magnitudes has got a little bit more spine to it. So now we need to find, let's see, that's 4 squared plus negative 2 squared plus negative 1 squared. And the magnitude of W is 6 squared plus 1 squared plus 3 squared. So it's the dot product divided by the product of the magnitudes. Remember, this is not theta, this is the cosine of theta. We'll need to do cosine inverse of this. So this is going to be, oh my goodness, that's 16 plus 4 plus 1. 16 plus 4 plus 1 is 21. And 36, I better make a note here, 36 plus 1 plus 9, that's not bad. 36 plus 1 plus 9 is 46. And so we have 19 over the square root of, remember the product of the square roots is the square root of the product. So I should be able to do 21 times 46 and get 966. And so if we want that as a decimal approximation, I have 19 divided by the square root of that value is 0.6113 approximately. Accurate to 4 decimals, that's 0.6113, rounded to 4 decimals, 0.6113. And so let me bring this over here. So if we have cosine theta is 0.6113, then theta is, this is an approximation, cosine inverse of the number we just found. And so cosine inverse of that, I don't have that. So let's try that again. Cosine inverse of 0.6113 is approximately 52.3 degrees. And again, as long as you show me your work, I will not be concerned with the precision of the rounding. If you have 52.4, 52.1, 52.5, any value close to that is fine by me. But that's the procedure. Cosine inverse of that value of theta, and that gives the representation of the angle between those two vectors.